So you're not going to be. So without any further ado, I'd like to ask my friend, Dr. Joseph Lindsay, to do his presentation on select soil and irrigation management practices for climate smart agriculture. Joe, the floor is all yours. The virtual floor is all yours.
Thank you, Steve. Good morning, colleagues and friends. It's a privilege for me to discuss soil and water management, which includes irrigation management, because it is felt that these things are quite important in the development of agriculture. As a matter of fact, they are fundamental to the development of agriculture in the world. And although we have been speaking about irrigation, by far the bulk of agriculture throughout the world is done by rain-fed agriculture. And it is possible to improve the use of the water which is stored in the soil by soil management practices. And if time allows, or through our questions, we can look at a few of them. So we look at climate change challenges. We look at some things about rain-fed irrigation strategies and water use efficiencies. We should bear in mind that Dr. Simpson spent quite some time yesterday going in details about soil conservation and other aspects of soil and water management. So in terms of climate smart agriculture, some soil constraints, we look at land use. We're speaking about water management efficiency, nutrient management, particularly manures, fertilizers, organic matter, and of course, the methods that we could do to improve our productivity. One of the primary practice in managing agriculture is land preparation. So after you have looked at the resource, the soil resource that you have in front of you, then you can look at land clearing and other preparations. In the small island developing states, there are very few primary forests left, and we don't think you should go around cutting down these forests. If possible, try to use tree crops and to use them for watershed management so that we can protect the natural resources. So of course you try to do, where possible, these clearing during the dry season. For example, in Haiti, much of the land has already been cleared. Most of the areas, or many areas, are denuded, but all large states such as Suriname, Guyana, and Belize, they have huge amount of land, so they may be having flat land which can still be cleared. I mentioned earlier that soil and water conservation practices were dealt in greater detail by Dr. Simpson, and in the land preparation, the removal of surface crusts and hard pans are critical if we're going to improve our irrigation, because the surface crust can prevent the entry or the percolation of water into the soil. Contour tillage and contour farming are critical. For example, there is a technology called sloping agricultural land technology, where we should, or it is recommended that we do contour farming practices, as this will help to conserve soil and water. Crop residues are quite critical, including cover crops, because we can then protect the soil surface from erosion, and we can also minimize the evaporation of water from the soil. We should bear in mind, however, that many agronomists will tell you that the crop residue mulches help to protect various pests which can do serious harm to the crops that we are growing. So we have to look at those. Prior to doing any agricultural activity, it is recommended that we do some preliminary soil assessment. And it is very difficult for the small farmers to do some of these in terms of the costs and the logistics. So if there are projects or watershed management groupings, then it would be better to do the assessment on that basis, as quite often the soils in a particular area we refer to soil series, they will tend to have similar properties, although there can be a lot of spatial variability in terms of soil properties. But it is critical that the farmer should know the soil properties, and they should be part of basic climate smart activities. So some of the common indicators in the preliminary soil assessments would include soil physical properties, the texture, that is whether it is sandy, silty, clay. It is very critical in terms of soil and water management and in predicting the behavior of the soil. So the structure, the depth, and in terms of water management, water holding capacity, critical. Soil pH, salinity, organic matter, and of course the nutrient status, fertility, looking at the major nutrients, the macronutrients, the secondary, and the micronutrients. So there are a number of organizations which can do the soil tests for us. The University of the West Indies has a well-known soil lab facility, which has helped to develop soil fertility guidelines for most of the English-speaking Caribbean. So it is important to learn of these at the outset. It is important in terms of the nutrients, to time the nutrients and to apply them on a regular basis so that the plant does not suffer extensive losses due to nutrient deficiencies. And there are alternative strategies such as foliar application, fertigation. Many times, particular nitrogen, this should be split. And if you are using manure and compost, these need to be added several times for the year. The organic matter is very important in terms of protecting the soil from the fixation of nutrients, and wherever possible, nutrients should be incorporated, covered, or irrigation should be applied. Most times we don't think of the soil biology, but the organisms in the soil, not only micro but also macroorganisms, are very important in decomposition of soil organic matter. In nutrient cycling, we speak a lot about carbon sequestration. They have a part to play in that, and in the aggregation of the soil. Biological nitrogen fixation is very important, particularly with legumes. And there are other means. For example, probably not enough emphasis is put on the role of mycorrhiza, which are fungi, which can help to increase the water and the phosphorus uptake, along with other nutrients in the plant. And there are many persons who are now using these inoculants as part of their management. Phosphorus is a problem in several countries, and hence we need to be concerned about that. So we have spoken about these things. So the nutrient management. So the alternatives to synthetic fertilizers, particularly the interest in organic agriculture, animal manure, plant meals, that is, any part of the plant can be broken down and turned into plant meals, which can be applied as nutrients to the crop. Green manure, compost, and we mentioned the agro-industrial waste and other byproducts. So we can move forward. So I was saying earlier that rain-fed agriculture is the main means throughout the world and in the Caribbean as well. And we need to be able to do more to benefit from this. And if there is enough rainfall, then there's probably no need for supplemental application by irrigation. But irrigation has several benefits, especially if you have a market where you need to produce consistently, then the irrigation can help you to maintain or to meet this demand. That is, all year production can be done. The crop yields can be increased, and there's better yield production than just depending on rainfall alone. Water use efficiency is not very good in many cases, and especially where there are irrigation schemes, people just put on water because they think it is relatively cheap, but probably 70, 80% of the irrigation, at least in Jamaica, is subsidized by the state. But we need to look at water use efficiency to improve the use of the small amount of water which we have. We spoke about reducing evaporation yesterday, and the best means to do that is to keep the soil covered, although there can be the interception by applying chemicals onto plants, but we do not think that this is a cheap method of doing that. There is a diagram which is showing that the water use efficiency, you want to relate the amount of biomass or grain or crop yield compared to the amount of transpiration or evapotranspiration. So the more production you get per unit of water which is utilized, the more efficient the system is. So some 50 to 60% of applied irrigation water does not benefit the plants to which they are applied. So most of that goes off in evaporation. And it should be the aim of the farmer or whoever is applying irrigation to be efficient in the irrigation management. So some limitations of irrigation setting in the Caribbean. The water supply is a problem because where it is, you cannot get it to utilize. For example, in Jamaica, a lot of water is on the north coast when a lot of the agriculture is on the south coast. So it's a problem. And then the quality of the groundwater, sometimes they are polluted. The management of every soils can lead to waterlogging, so that is important. And salinization is a big problem in terms of irrigation. In terms of the data requirement, if we go forward, the land classification or the capability, the type of topography, the soil depth, the texture, the structure, the water holding capacity, the potential of the area, the existing infrastructure, water source, both the quantity and the quality, and the power source is another big issue. There are many persons who are talking about in a chat I've been on about the power source. So the available water supply, I have several of these already. In terms of water distribution, only about 3% of the total water in the world is fresh water. And of this fresh water, there is very limited amount which is available for agriculture, and therefore this needs to be used very efficiently. So the importance of irrigation versus rain-fed agriculture is very critical, and the contribution of irrigation to production must be looked at. As we hurry on, there are various irrigation systems: surface, subsurface, drip, sprinkler, center pivot. And of course, we know that the drip irrigation is the most efficient system, but there are situations where drip irrigation is not the best But there are several advantages of it, which you can look at in detail when we provide you with the handout. Drip irrigation systems are also important because if you elevate the water source just a meter above the area where it is being applied, there is enough energy for this water to be properly distributed. With sprinkler irrigation, there are certain challenges, but it is still very critical. And for certain crops, sprinkler irrigation is preferred over drip irrigation. And there may be areas that need to be managed. For example, the pressure management, the use of under canopy application, especially in areas where there are high winds, applying irrigation during periods with low wind speeds, especially early morning and in the afternoons, and it's possible to use windbreaks. So some water-based challenges include water conservation, harvesting, flood control, land gradation, managing the watershed, and including agroforestry and the development of the infrastructure. The various water sources, rivers, springs, wells, we need to do more constructed reservoirs and water catchments from homestead, greenhouses, animal shelters, and even the storage in holes or cavities. For example, in Jamaica, where the bauxite mining has occurred, there are lots of caverns which can be lined and be utilized for storing water. And then we can collect runoff water, which Dr. Simpson was showing yesterday in his presentation. The recycling of waste or gray water is not common in the Caribbean, and this is something that needs to be looked at. The power for irrigation, small engines, solar powered systems, but this is still quite expensive. If you can pump the water into some elevated tank, and then this can flow by gravity, this would help. Tractor operated pumps, and in certain places, hand, foot, and bicycle pumps have been used just to raise the water to an elevation where it can be readily used.
Dr. Lindsay, as mentioned, you have 3 minutes left.
Thank you. So in closing, select challenges in implementing irrigation strategies. There is inadequate baseline data. We need more information on crop requirements, soil properties, and weather, as Dr. Rankin alluded to yesterday. Changes in the local weather due to climate change is a problem, so you cannot predict planting on Easter Monday as used to happen in the past. Lack of information on crop water use, inadequate cooperation about stakeholders, and the high cost of capital. So there are several irrigation adaptation strategies which I've mentioned, and micro irrigation schemes, micro catchments, increased storage in the soils, utilization of gray water, harvesting and reuse of drinking water. And we hope that these, and I'm sorry that we have had to rush, but at least I'm available to answer any particular questions that you have, and in due course, the organization will provide for you the handout we have prepared. Thanks for your attention, and I'm prepared to field your questions.
Thank you so much, Dr. Lindsay. The floor is now open for questions. You can either use the raise hand function or list your questions in the Q&A box. As per our initial insistence at the start of this webinar series, we're here to give you an opportunity to interrogate the information that we are providing if you want to have knowledge transfer accumulation. So we deliberately left a larger segment of time available for questions and answers. So please utilize it. I'm seeing a raised hand. Can you go ahead, Michael?
Hello, good day. In doing research, I found it like kind of hard to find data on the groundwaters and aquifers within Trinidad. And I know in America that they do have depletion problems with high levels of irrigation, especially sprinkler irrigation, due to like high levels of evaporation. So they're in a small water crisis in certain states. I'm just wondering how sustainable some of these irrigation practices are.
All right, Dr. Lindsay.
Yes, the irrigation is critical. For example, in terms of applying water, there are times within the plant cycle where irrigation is more critical. That is, of course, what germ is the time for fruit set. It is important that adequate water is fed. In certain underground water supply, so they could tell you where irrigation. You could look at the most efficient method of applying the irrigation. That's what we're saying, that where feasible, drip irrigation is the best in terms of the water use efficiency and the conservation of water. But there are applications where sprinkler irrigation is more suitable. And there are many companies which can help the farmer to design the systems. Fortunately, in Jamaica, there is a National Irrigation Commission which has a number of facilities in different parishes, and they are a major help to the farmers and large schemes to be developed. They will assess the Water Resources Authority in parts of the Bahamas. They do not, that restricts where you can do a well and so forth, but it is quite readily managed in Jamaica, and even for extracting water from rivers, there are regulations. So there are opportunities where we can look at best practices and utilize them. So I hope I have thrown some light and not confused.
Okay, whilst does that response, let me just read a question from the question and answer box. I'm going to read it verbatim, and Dr. Lindsay, you can see what you make of this. What are your thoughts on as regards water smart agriculture on soil smart practices? As I said, I'm selling it as I bought it.
Yeah, well, that is what I was trying to do. The presentation was suggesting some of the ways, because prior to doing the irrigation, it would be good to know something about your soil property. Very important to know, particularly the texture of soil, the depth of the soil, the water holding capacity of the soil, and then the crops that you're growing in terms of climate smart agriculture. You want to utilize crops that can provide returns either for animal feed or for local consumption or for agro-processing. So these are some of the issues which we want to integrate. That is the soil facilities, the best practices in irrigation, and the choice of the best crops which can bring return to the farmer.
I'm not seeing any raised hands or questions in the in the box, so I can just use my prerogative a bit to spur on Dr. Lindsay. Region with projects of that nature.
I've seen a number of them where the focus is on agriculture. For example, in the bauxite belt, they have been harvesting water both from greenhouses and from runoff into lined ponds, and then this has been recycled for irrigating the crops in the greenhouse. I think the water harvesting projects must all be integrated into the production of crops. If the temperature allows, protect cultivation, give you returns on your investment. And where livestock are available, you can utilize it for your livestock. There are some places where people rear fish in this water. So it's an integrated thing. Some persons are even doing ducks, and then there are a few people who are actually using some for aquaponics.
Thank you. Let me just check the
Hi, Steve. So there are two
question
questions
and answer.
in the chat. So you can probably just go to the chat.
Please, go ahead, please. Oh, in the chat. Can you please recall them? Desi, I'm on the questions box.
Okay, so the first,
Desi?
yeah, I'm going to read them. So someone asked, I think it was Mary, Dr. Lindsay talked about mulch protecting harmful pests. How does a farmer balance this? So Dr. Lindsay?
Yeah, I was saying that some persons are, well, not some persons. We know for a fact that so that you crops integrated pest management to try and minimize the problem. Mrs. Harris or the entomologists, their turn can provide additional information. Dr. Simpson would mention today that the albedo, the color of the mulch, sometimes provides a plant protection effect in that because of the reflection of the light. And minimize attack from protection for certain predators, which would be on the snow, that slugs and snails are notorious in certain locations where mulches are used, and especially where it's kept moist by regular rainfall. So there need to be other attempts to control these pests and diseases.
And the other, Desi?
This is more of a comment, but Brenda Lee Samuel Chance, she was basically saying, is it safe to say that how regular a plot is irrigated is dependent on the life cycle of the crop or the status of soil water availability?
Water, bear in mind there's a lot more water and the harvest index for a crop like Irish potato or pepper, they're very good in terms of
Of another question from the floor. Oh, let me just take this question from the floor. Are you familiar with the aquapot watering system? And can you speak on its viability?
No, I think Dr. Rankin could speak on it. I don't have intimate knowledge of it. I've heard of it, but I've not actually used it. I've used like the tensiometer yesterday. Dr. Rankin mentioned the tensiometer, and then he will show us an improved method for assessing the water. I think the tensiometer is very good in determining the soil water and what the plant is experiencing. And there are some of them which can be automated. So you can be in your office and you'll be able to, or your home, and you can interpret what is happening in the field in terms of the water status. But as I pointed out, once the soil becomes too dry, then the whole system breaks down.
Can I ask Dr. Rankin to comment while the topic is still fresh in participants' minds? Dale?
Sure. Good day, everybody. Can you just run back the question again for me, please? What was the question?
Are you familiar with the aquapot watering system, and could you speak to its viability? It seems very expensive. Aquapot, A-Q-U-A-P-O-T. The aquapot watering system.
No, I have not personally used it, so no, I don't know what it is.
Okay, Maki, what we will do, we will get an answer from you and we will post it in coming chats, and we will contact you individually as well.
The only thing I know is that it is they regard it as an exceptionally new concept in self-watering containers, and I think the inventor is a guy called Jack Barnwell, but it's not.
Come question to read out. So could you please bear me out, Dr. Lindsay? I'll read. Should we also use climate smart crops in terms of growing specific species of crops that prefer and grows best in various weather patterns, rainy as opposed to dry season, and adapt our diets to suit? And should we become more focused on tree crops in terms of the integration of them in farms, in mixed cropping systems, as a form of protection for smaller and less robust crop species? Dr. Lindsay?
That's for me? Okay.
Yeah, that was for you.
Yes. Well, there are many persons who believe that we should integrate our farming system so that we should have a mixture of permaculture in which the tree crops or agroforestries can be incorporated. But for many persons, the plots which they have, the farms are micro farms, very limited. And persons tend to produce things based on what is happening in their surroundings. So it's very variable. I don't think you can give a straight answer, but it should be considered that where possible, we should use a range of different crop types. And I was also mentioning that for irrigation, if you have only a limited amount of water for irrigation, it doesn't make sense to go and plant your own farm with a particular crop. And if the drought comes, then you lose the whole thing. It is better to select a smaller section that you can adequately irrigate and manage so that you can get returns from it. But the watershed approach, then you could have diversification of the crops. But for the average farmer that I'm aware of, the range of crops has to be limited in terms of the labor and the market and the knowledge which the farmer had. But for each crop, there can be increased knowledge about irrigation management, and there are some basic principles which we can use for managing irrigation, irrespective of what crop it is.
And whilst I have the floor,
Um,
can you say?
Steve, can I say something on this question?
Go ahead.
Can you just read it? Can you just read the last part of the question again for me, please?
Removed from the chat. There was a lengthy comment that has been removed from the.
Yeah, the last part, the first part was talking about the climate smart, and I have a response to that. But the last part,
Hold on 1 second. Let me see if I can read it again. The last part says, and should we become more focused on tree crops in terms of the integration of them on farms in mixed cropping systems as a form of protection for smaller and less robust crop species?
All right, so I have 4 comments to answer that question. First of all, Steve, one of your pet peeves is people talking about water harvesting project, yeah? And you have said that there's quite a water harvesting project. And you're quite, to a large extent, you're right. I want to say, no, I want to posit this morning that there's no such crop as a climate smart crop, right? There are climate smart technologies that can be used to make your farming system climate smart, but there's no crop that is climate smart. The crop doesn't know that today is 30 degrees Celsius at all, so there's nothing smart about the crop. That's the first thing. So what we can do with things like crop simulation modeling is identify the things that the limits within which we can grow, and then determine, okay, if this is the limit of the drought tolerance, then beyond this point, the crop is going to fail, right? And then we can start looking at what kind of irrigation system we should have and so on. So that's what modeling can do in the first place. Now, the good thing about the modeling is that you can experiment with several different irrigation schedules. You can say, irrigate to a certain level of field capacity. Once the water depletion, and that's my next presentation, once the water depletion reaches a particular level, irrigate again. You can do that. So there are means of doing that, several ways of doing that. You can say, I will put water when I want. You can have tensiometers, you can have moisture sensors. I'm going to show a video of that just now. The second thing, though, is that we can alter, rather than altering our diets, we can alter our cropping season. And we had a clear classic example of that. And I've told this story every time I get a chance. You know that the Caribbean exports banana to the UK. An entire shipment of banana was sent back from St. Vincent and the Grenadines. Not even one was eaten. It turned out that there was one letter that was sent, Steve, one letter. The person reminded me of Steve Maxime, because they wrote very short. They said the bananas are too curved. That's all. There was nothing else. The bananas were ripe, they were nice. So, of course, they came to UWI. We had to do the research, and we found that the curvature of the banana is dependent on the amount of rain that it begins to ripen. And we were farming at the same time, not recognizing that the rainfall pattern had changed. So that is where applied research comes in. We have to look at what is happening. Jamaica, all Caribbean countries have, we call it a bimodal rainfall pattern, where we have a primary peak in September, October, and a secondary peak in May, June. Well, in Jamaica, that has been reversed in the last 20 years. We get more rainfall in May, June, and less in September, October. So if you're not looking at your cropping season, you're going to plant at the wrong time. And that is what modeling allows you to do. The third quick thing is that we have to make healthier food choices. A number of things that we are accustomed to eating and almost acclimatized to eat from when we are small are not good for us. A lot of the wheat that we get, 90% of it is genetically modified. So as soon as you pass 30, you get diabetes, hypertension, all of those non-communicable diseases. So we have to get better health choices. And the last thing about tree crops is not a be all and end all. Yes, it is good in principle, but we also have to bear in mind that where tree crops are concerned, there is a problem in terms of the length of time it takes before you actually get the return on it. So a mango tree takes 3-4 years, during which time the farmer needs a livelihood. So we just have to bear that in mind. So that's my point on that. Thank you.
All right, thank you, Dr. Rankin. We are dangerously close to the changeover time. And since we are on a roll, I think we'll just take Dr. Rankin's presentation and then answer all the resultant questions afterwards. Now, I know that Dr. Rankin does not want me to do the usual lengthy introduction.
Yeah, please don't.
But I think I'll be selling the newcomers short if we don't, just say a bit about who you are and what authorizes you to, to have this type of discourse. Dale Rankin is an applied climate scientist in the Department of Physics at the University of the West Indies, Mona. He was a PhD in physics with high commendation and worked as the agricultural climate modeling research analyst under the regional track of the PPCR. His research interests are climate and crop simulation modeling, and more broadly, assessing climate change impacts on the socioeconomics of the wider Caribbean, and I might add, from personal experience on the world. Dr. Rankin is a member of the Climate Studies Group, MONA, which, as you know, has been active in climate research over the last 25 years. I have great pleasure now, as I mentioned in the beginning, to introducing my friend, Dale Rankin. Dale, could you go ahead with your presentation?
Thank you very much, Steve. I'm so undeserving of that introduction. But since you insist, all right, I'm not going to use my video. Everybody knows me. This is Dale. Thank you very much. Thank you for being here. Thank you for inviting us into your space. All right, Mr. Chairman, I am going to try and be as time conscious as I was, so my time starts now. All right, I want to direct everybody's attention to the document that is on the screen. Can you see my screen, sir? Are you seeing a table on the screen?
Yes, sir. No, not yet.
No?
You have your menu.
All right, hold on. What is happening here? All right. Let me see if I can. Are you seeing anything now?
Yes.
You seen a table?
Yes, I'm seeing it.
All right, good. All right, so everybody would have gotten this table from Desi, our faithful friend Desi. And I want to explain what it is before I go to, so let me just explain to you what we're going to do. I'm going to show you some readings of soil moisture to try and tie the two presentations on irrigation together. When I'm finished that, I'm going to show a video. Now, the video is 39 minutes long. We're not going to go through the whole video. So I'll skip through a certain part. But if you want to get the full video, it's available on YouTube. Desi will share the link with you, all right? But I just want to show you really and truly what we're dealing with. So the format of the presentation is this. I'm not going to do a PowerPoint. I'm going to explain the table. I'm going to ask a few questions. After that, we're going to look at the video, and then we have a little quiz. It's a multiple choice quiz. It tries to tie together everything that we have heard. It's self-correcting. So once you've put in your name and the name of your institution, you click next. The 10 questions come up, you click. Once you finish, click, make sure you check your answers. Once you click submit, you can view your scores. It tells you how much of 10 you get. All right, if you get more than 7 out of 10, you pass, right? Is that fair, Steve, or I should say 6 out of 10?
6 out of 10.
All right, 6 out of 10, you pass, all right? And PPCR will be very happy to hear that, all right? So it's very simple, and it shows you the answers. If you get it wrong, it shows you what the answers are. And I believe we can do all of that. Considering Steve, we would have had some time for question and answer. I'm interweaving all of that in this time that I have, right? Okay, so if you look at this table, what this table is telling you, if you look at the bottom here that says water holding capacity, it is telling you for each of these soil types, what is the moisture holding capacity of the soil? And the soil types are silty clay loam, silt topsoil clay loam, upland silt. Everybody see where I'm reading from? Bottomland silt loam, fine sandy loam, loamy sand, and fine sand. Can everybody see that? Everybody see that in the second column here, second row here? Yeah. You have to talk to me now. I'm a teacher. I have to hear you.
You know there are figures there, but at my age, I'm not sure if I can tell.
No, Steve. You are hopeless. Don't worry. All right. So now go down to the bottom of the table where there's a gray bar there. And you will see the moisture holding capacity. Can anybody tell?
Dr. Rankin, not to cut you, but is it possible for you to zoom in a bit or because a lot of the participants are having a difficult, that helps. And just realign it. Thank you so much for that. Well, you
Alright.
type back over a little bit. Yeah. Yeah.
Good. So can somebody know, I don't know how I'm going to do this. Can somebody now tell me what is the moisture holding capacity of the soil called fine sandy loam? How many millimeters of water? It's right there on the screen. Can you type it in the chat and tell me what is the moisture holding capacity of fine sandy loam? Let me see if anybody can get that.
Gina already got it. Gina Pierre already got it.
What he said?
She.
What did he say?
150.
150.
150. Excellent. All right. Just one more. Can you tell me what is the moisture holding capacity of the silty clay loam? Silty clay loam? Anybody get it, Chair?
158.
Between 150 to 166. Okay. Now, on the left column here, what you're seeing is if you went into the field, this is what you would typically see on your moisture probe or on your tensiometer. And remember what we tell this reading is, it is telling you the pressure or the force that the plant has to expend in order to get water. All right, let me say it again. It is telling you the amount of energy or force the plant has to exert in order to get water from the soil. In that case then, what would a value of 0 represent? Would it say that the soil is wet or the soil is dry? Can anybody tell me?
You have an answer. Wet.
Wet, very good. So the higher the value, the drier the soil. Okay, so here's a question I want to ask now. For the soil called upland silt loam, can you tell me what a reading of 70 is telling you? How much water has been depleted at that point? When you scroll across from 70 to upland silt, can you see how much water has been depleted at that point? Anybody see that?
2/3. What is it? Uplands.
Upland silt loam, when you have a reading of 70 on your tensiometer or your moisture probe, how much water has been depleted? Anybody see?
One says
100.
49.17.
49.17. Excellent. Excellent.
Well, I can't take the credit.
50%, yeah.
All right. What about silt loam? The same reading. Same reading. Silt loam for 70. How much water depleted?
41.67.
75%.
41.67. 41.67. What about sandy loam? Same 70? Same 70. Sandy loam? Anybody can tell me?
Someone says 66.67.
Excellent. 66 or 66 and 2/3. Okay. So what are you noticing? For the same reading, depending on the soil, the water depletion is different. Can anybody tell me why? Why isn't it the same amount of depletion for the same reading?
Water holding capacity.
No, Doc, you can't answer. You know. Right. Can anybody else tell me, apart from Steve and so on, why is it that when you have the reading, you don't have the same level of depletion? Why is it changing?
We're getting from the chat that is water holding capacity varies.
What? Yeah, but a little bit more than that. Anybody else?
One person had said soil properties are different, texture.
Yeah. Yes, and therefore, the answer is, that answer would get 7 out of 10. The properties are, the soil thing, they are different. Each soil has a different water. Some retain more than others. Yes, we're getting, yes. We reached up to 8.5 out of 10 now. We're almost there. We're almost there. It's almost there. Therefore,
Size and soil particle difference. Soil particle difference sizes.
yes, almost. That's it. We now reach 9 out of 10. Soil porosity, 9.1 out of 10. Somebody's holding back on the answer now. All right, we get it now. So Kimberly Core put everything together. So these soils moving from clay loam on the left-hand side to fine loam to fine sand on the right-hand side are soils that are varying in soil particle size from smallest to greatest. So for the clay loam soil, you might have a lot of water, but it's not available to the crop because it bonds very strongly to the particles. Whereas sand, for example, is a different thing. Now, look at what is also happening. These values tell you, once you go to the tensiometer and you read this, it is telling you how much water has been depleted. And it is also saying, once you get a reading of this, it's time to irrigate. So these values are saying it's the trigger for irrigation. So that's the most important thing you learn from this. When you go in the field, right, if you see 80 and you go over to fine loam, fine sand, 80 say, yes, you have to irrigate right away. 80 say you have to irrigate right away. But when you look at silty clay say 54 point something. But let's just take a different value. Let us look at a value of 33. A value of 33 in the table for clay loam, for silty clay loam, for example, it is saying you have depleted by 16.7 and maybe you need to do some irrigation. Why? Because the moisture holding capacity is 150 to 167. When you look down the bottom, it is telling you the trigger point. The trigger point for irrigation is anywhere between 70 to 80 kilopascals. So if you go in the field and your reading is saying greater than 75 for this soil type here, it says you have to irrigate. That is what it is telling you. So it gives you both the trigger point in terms of the amount of water, and it gives you a trigger point in terms of the actual reading itself. So if I go in the field...
Dale, can I interrupt you? Sorry. There was a question, a comment in the chat. Someone wanted to know what a trigger point is.
When a gunman hold up to shoot, just kidding. The trigger point is a point that tells you at this value, you need to turn on your irrigation system. All right? So it is a trigger for irrigation. That's really what it means. So if I go in the field and I am looking at silty clay loam, for example, the trigger point for irrigation, or the point at the reading at which you should irrigate, is if your gauge is saying anywhere between 70 to 80 kilopascals. So if you go in the field, for example, and your reading is saying 50, you don't have to irrigate because the soil has enough moisture. Are you with me? But if you go in the field and it is saying 81, then you have to irrigate. Is that clearer, Chair?
Yes, but you can't judge me. I'm not as bright as the participants.
No, if you understand, everybody else understand.
Okay, well, that makes sense, yeah.
All right. So that is something that is important. Now, the 3 key points you need to get from this table. Number 1, the amount of water that is in the soil varies with the soil type. So even for the same reading, it will have a different meaning. So when somebody come and tell you, say, boy, but just turn on my irrigation system, because I went in the field and I saw 70, you should go and turn on your 2. First thing you must say to them, what kind of soil you have, right? And if their soil and your soil is not the same, then you have to know what your soil type is. So that's lesson number 1. Lesson number 2 is you must know what is the water holding capacity of your soil. We have given it to you down here at the bottom. This is the moisture holding capacity of your soil. So you must know what is this is the readily available water. That is the amount of water that the plant can get between field capacity and permanent wilting point. You must know this for your soil. All right. Now, these soils are soils from, I think, Alabama. So don't go and say you need to say bottomland and topland. These are not Jamaican soils. All right. As the eloquent doctors were saying, Dr. Lindsay was also pointing out as well, is that this is available from your soil people. They will tell you. The third lesson is at the bottom of the table now, the last row, it tells you the what reading. Let me not use trigger point. These are the readings. If you get these readings, it's saying you must irrigate. All right, so those are the 3 key points. Again, the soil varies in the amount of water depending on the soil type, number 1. Number 2, the water holding capacity of your soil. And number 3, the point at which you must irrigate. You will notice, for example, finally, that sandy loam has a trigger point of irrigation of 30. So once you go in the field and it reading 30, boom, you have to irrigate. But when you go across just the soil beside it, and you look at a soil like fine sandy loam, it is saying it can go up as high as 55, right? So plants have different tolerance level in terms of irrigation, all right? That is as much as I want to say about that. You will see that again in the little quiz that is coming up, and the quiz can take about 2 minutes because it's very easy. All right, so let us go to the next thing that I want to do now. The next thing that I want to do in the 8 minutes that I have left, Mr. Chairman, is that I want to present now. I want to present the video now. I really wanted Desi to run the video for me, but when I checked back and saw that the time would not allow for that, I said, well, it wouldn't be fair. So anybody hearing anything? Chair, you hearing anything?
We were hearing, but it stopped.
You were hearing, were you seeing it?
Yeah, I'm seeing the opening.
All right, so all right, I'm going to ask you to tell me when you see it.
You're scrolling through. You're scrolling through the
All
presentation.
right, tell me, are you hearing anything now? Hearing and seeing?
Not yet.
Tell me when. Anything?
Nope, it's on slow-mo though. I'm not here.
No. I'm just asking if you can see the slide. I just want to know if you can see it before I continue to play it.
Yeah, we're seeing it, but I'm not hearing.
All right, tell me if you're hearing everything.
Yes, we are here now.
Yeah, we're hearing now.
All right, great. All right, so I'm going to run it for a little while.
We're not hearing now.
Dr. Rankin, we're not hearing. Do you want me to pull it up and start playing from that 2-minute mark?
Say again? What you saying, Desi? Desi? Hello?
Sorry, Dr. Rankin, that we're not hearing when you're playing it. I can pull it up and start playing it from the 2-minute mark that you had started.
All right, go ahead, Desi, go ahead. I'll tell you when to skip ahead.
While that is being done, do they want to give us some background into the video?
Right, so what happened is that we have historically, and thanks for that, Chair. Historically, we have just been measuring relative humidity, temperature, air temperature, that is, solar radiation, wind. We have looked at solar heat flux, and we have looked at, of course, our traditional variables like people have looked at evapotranspiration and so on. What we have not looked at is what happens. Go back a little further. All right, yeah, you can stop right there. What we have not looked at, Mr. Chairman, is soil moisture, because what happened is you get rainfall, but of course we just saw that the amount of water in the soil varies with the soil type. So the World Meteorological Organization came out with this requirement that you must start measuring soil moisture as one of the routine variables for every Met service in the Caribbean. I worked at the Met service before. They knew my experience and expertise in this area. They asked if I could install 18 soil moisture probes across the island. Now, at each site, we install 2 moisture probes, one at 6 and one at 12 inches. That's because where most of the root zones are. And so we were demonstrating how that is done. So that is what the video is about. I'll talk a little bit more because time is going. Go ahead, Desi, please. We're not hearing though. Hearing the audio.
And the soil temperature probe at 2 levels. The idea behind it is that when we are able to more properly and more accurately monitor soil moisture, we're in a better position to do improved irrigation management. So I'm very happy to introduce the members of the team this morning, Mr. Irvin. Mr. Irvin We have Mr. Andrew Anchard, and Mr. Pearl Beecher, and Mr. Charles Reed. All the equipment that we have actually brought together will actually be used in a very strategic way. And at the end of the day, when we actually started this installation process, it was taking us, what Mr. Irving, about an hour and a half. We have actually managed to refine the process that now we can do an installation in about half an hour, give and take a few minutes. At the end of the day, if you look across there, you'll see that there's a weather station. And that weather station actually is going to be within 1,000 feet of where the probes will be planted, so that the communication can be between the two consoles. And therefore, when data is being downloaded from that weather station, it will also have soil moisture information and soil temperature information. So that's really, really important for the improvement of agricultural practices across Jamaica. It is going to give us a good sense of what is happening on different soil types in Jamaica, so that we'll be in a better position to improve our irrigation scheduling for agricultural production. Here we have the tools and equipment that we'll be using to execute this installation. In my hand here you have 2 lengths of 1/2-inch PVC pipe. And what this will do for us is basically serves as the housing for the cables that we'll be using. In the bottom, you'll find the cable, which is the probes. That is soil moisture probe. Those green cables, the probe is actually at the end of the cable. We'll be installing 2 soil moisture probes at different levels. One will be 6 inches below the surface, the other will be 12 inches. The probes are actually submerged in water. This is actually done overnight to basically calibrate these 2 instruments there. Digger that we will use to plant the temperature probe, the temperature sensor, the drill also. So this is basically the temperature sensor at the end of the cable. You have the sensor. Temperature and soil moisture sensors will be placed in this conduit and submerged below the surface at different levels as I've indicated. That's the drill that we'll use there. These are the conduits that we'll plant the sensors in. First, we will select a suitable site, which in this case, we have selected the center of this field there. The poles will be planted, the cables will be laid. So you'll have to create the channel for your cables. The cables will be inserted in the conduit. Then what we'll do is the connection of these cables. The connection is basically for the communication between the console, which will be housed in this office there, and the ISS board, which is the sensor for the communication of the data from the sensor. Yeah, so what we have here is a display of the data that would have gathered from the ISS, which is planted on the pole over there. So the readings that you would expect from this are 12 inches and that's 6 inches. Right? And if you can see this display board here quite clearly, just by a knock of the buttons, and the readings will be there. This has a capability of giving us the real-time data as well as stored data. Stored data we will retrieve from downloading the information from this console. And from that, we can actually have a better readout as to what the readings are over time. So here are the displays of the different readings. You can get the temperature at level 1 and level 2. So level 1 being 6 inches, level 2 being the 12 inches. What we're having here is the weather station, which is the Davis weather station. On top here, this is the rain gauge, or the funnel for the rain gauge. Relative humidity sensor, temperature and humidity. This is the housing for it. This is the ISS board, which does the communication between the soil moisture sensors and the console. And that's the wind sensor. Over here, there's the wind sensor. Basically, this gadget, we're able to get the different meteorological components from it. We are now at the point of installation of the probes, of the soil moisture and temperature sensors. So we would have initially come out into the field and do our survey. And at that point, we would have
selected the ideal location. Stability of the pole is very important. This is something that is going to be here for a period of time. Say it cannot be feeble because then it will be easily toppled. Okay, the ideal location is more like a flat of land. Now, you will not always find the land in a very level and ideal situation. There are times when the land may be sloped, right? So at that point, for example, this land, if you notice, it is slightly sloped in this direction. So would have considered that point as a high point. Down here is a low point. Now, it would not be suitable to put it at the top, right? Because then you would have, for example, we have rainfall. The rainfall would be more channeled towards this side. So the water would not be, it would not be a true representation of the water that actually goes down into the soil. So we try to get the most ideal location. You would not put down the side. If we plant a pole there, then you would have, it's quite possible that you would have ponding down that side. So there would be like settling of the rainfall. So we do take the north-south orientation into consideration when we're actually placing the ISS board. You notice there is a solar panel on it. So the north-south orientation is very ideal. Would actually place this to the south of the pole. In that location, you get maximum sunlight. And the sunlight is ideal for the charging of this. If you see right here, basically a solar panel. All right, so we have south.
So is that direction. So the solar panel is going to face that way.
That's way. Yeah. We're now mounting the ISS board.
Yeah.
To ensure that it's well secured. Like inside the box here, we have temperatures. That is the wire to the left, soil moisture probe, to the right.
To the right.
Okay. Notice for each temperature and soil moisture, you have 1 to 4. You can install just as many probes
on the different channels.
On the different channels here. In channel 1, what we'll do is wire probes at a 6-inch depth.
Okay.
And in channel 2,
yes,
we'll wire the one for a 12-inch depth.
And you do the same thing. So if you use channel 1 for the temperature depth at 6, you use channel 1 and the size moisture for 6 as well.
Okay. Okay. One on each side would be for 6-inch depth. One on each side would be for 12-inch depth.
I also noticed that they are differently colored as well. Is that the coding to make sure you don't make any mistake, right?
Yeah.
So channel 1 has two I guess that's for positive and negative, I imagine.
Yeah.
Right, and the two of them are colored blue. And then channel 2 is colored gray, and then channel 3 blue, and channel 4 gray.
So there's no mistake. What we do is wire, we would run
the cable through that
right through,
okay,
and secure it right there, so that it has a snug fit. This is our antenna that relays back to our station that is over there. Yeah, the probes would be implanted at the end of the conduit there, and then the wires fish through the conduit right up to the pole and then connected. You can secure the soil probes into the 6 and 12 inches pipes using super glue, and then they cover it up with silicone. The cable have a section to come up, so we put that cap on it.
Desi, can you move forward to the summary by me at the end, please?
Can we fast forward to the actual test, please?
No, the summary. There's a summary by me at the end that just go over.
And the test of the equipment? No.
Yeah.
On the laptop, yeah.
Like here.
No, further. Further. Let me see. Go further. No, come back. Yeah, go back a little bit more.
Just a little bit.
Yeah, go there, yeah.
The thing that we actually did was to dig a trench right here from where the post actually is to the end right there where we actually installed the probes themselves. To determine the ideal location to plant this first of all, this console, ISS control, we first of all have to use our compass to measure the north-south orientation. That's important because once this space is south, you get the maximum sunshine duration. And that is important. Very, very important all the time. It has a solar panel here, as you can see. This powers it during the day, and there's a battery inside that powers it during the night. So once we've actually fastened this by using two U-bolts here and the nuts, once we've done that, the next thing that we did was to run the cables. Here we have two green cables. These green cables carry the soil moisture signal, and the two black cables carries a soil temperature signal. All right. Now these are planted at two different depths. They are planted at 6 inches depth and 12 inches. The 6 inches being the shallower depth, of course. And the reason we limit it to those two measurements, those are the two locations where the largest concentration of root depth for the crops are located, and therefore the location where you'll have the greatest extraction of moisture. Once we've actually run the cables, there's a conduit that actually is underground. Now you can't see it, but it runs through the conduit. And at the end of the conduit, we have the soil moisture probes. So over here, the probes have been inserted in the ground. We leave about 3 feet above the ground, and we insert at the end of this PVC conduit is a soil moisture probe at 6 inches. How we know it's 6 inches, we actually flag it with a pink tape. And at the end of this one is a 12 inches probe, and we flag it with an orange tape. It's important for us to note that, because at the end of the day, when we come to measure, we want to make sure that we're accurately measuring the correct depth. Immediately beside the soil moisture probe, if you can see this black lead here, this cable, is a soil temperature sensor. This is planted immediately beside the corresponding sensor, and it's planted directly into the soil itself. It doesn't go into a conduit. All right. To the right of this pink marked soil sensor, soil moisture sensor, is a soil temperature probe for 6 inches, and it's buried in the ground at exactly 6 inches, the same depth as the soil moisture probe. Once we've done that, we cover the area to ensure that the conduits are buried underground. This is to ensure that the cables are safeguarded. All right. We use just a pole here to mark where the probes are planted, so that at a glance through the farm you can actually see it. It also ensures that when plowing is being done in the farm, nobody will plow up the station. Final step, once we have done that and we have had everything done, is to in here connect all of the cables in the correct port. Now there are 8 different channels. Each port has a positive and a negative lead. On this side, you will see that we have temperature. On this side, we have soil moisture. So it's color coded. Each channel is alternately labeled gray or blue. So channel 2 is gray, channel 3 is blue, channel 1 is blue, channel 4 is gray. We have used channels 2 and 3. Now it's quite noteworthy that because we have used channel 2 for the 6 inches here at Green Island, for the soil temperature, we use the same channel for the soil moisture. We have used channel 3 for the soil temperature for 12 inches for the soil temperature, and then for the corresponding soil moisture, we use channel 3. Now, once we have done that, we ensure that the battery is put in place. Now, this is a 3-volt battery. It's put in place, and it's important to maintain the voltage, because here we have a solar panel. This powers it during the day. But of course, in the night, when there's no sunlight, solar energy is down, you would actually need a battery to keep powering the station. The very last step inside here is a very tiny series of switches. And what we actually do is to flip the one marked channel 2, and that station 2, what it does, it allows the automatic weather station on the hill that we're going to connect this to recognize this as another station. So that when the parameters are being measured, apart from the temperature, the relative humidity, the solar radiation and wind, it will now start recording soil temperature and soil moisture at 2 different depths, 6 inches and 12 inches. Now that we have had that, the last thing we do is to try and close our console here. Antenna will be sending the signal shortly, and then we'll be demonstrating that actually it is in fact measuring both temperature and soil moisture at 2 different levels.
Can stop now. Can stop now. Thank you very much. All right, we apologize for the quality. I mean, you'll get it in your email. I mean, it plays quite well. There's no delay between the audio and the video, but you get the drift. Anyways, in the chat now is the link to the quiz. All right. I mean, if you don't have the time to do it now because you know we're almost out of time, it's fine. But it's a multiple choice quiz, all multiple choice. If you click on the link, enter your name, enter your institution. Once you do that, it takes you directly into the quiz. You click the correct answers. When you click that, you click submit, you click view score, you see how much you get. All right. As you get your score, you can just post it in the chat. You know, I got 9, I got 8, I got 7. All right. Once you do that, then you see what happened, and then we'll see whether we were good presenters or bad ones. All right. And whether the moderator did a good job as well. You have to put that in as well. So I yield to you, Chair.
It's about time. I'm deliberately not responding to any of those probes, whether they were at 6 inches or 12 inches, because the skin is a lot thicker than that, Dr. Rankin. I can assure you that the participants are, you know, really engrossed in the information, if not the presenter himself. But I can tell you that there are a number of questions that we'll try to address.
Okay.
Right, so let me start with one here. Okay, Dr. Rankin, these models you refer to, when you mention charging management variables, example irrigation, do these models have the flexibility of choosing different varieties of a crop? No. Or are there any plans to parameterize models with different crop varieties?
Excellent question. Depends on the model. So the aqua crop doesn't do that. The on-some model, on-some average of all the varieties you're planting. So for example, when we were doing the sweet potato trial chair, we had 4 different varieties, right? One variety at the same location gave like 5 tons per hectare. The other one gave about 25 tons per hectare. So you understand when you're taking an average across that, it really doesn't tell you very much. But remember, it's a simple model. Unlike the C-SAC model that we work with Steve, right? When we were doing the work for the Ministry of Agriculture, that one now you can tell the exact cultivar. And if your cultivar is not inside the model, you can build a new cultivar inside the model.
Yes, including ganja. The variety ganja.
Another question here. And just to allay the fears of fruitful ball, the little quiz that we have now, whether you were able to hear the presentation or not, it's not going to affect it. All right. It's a lot more simple than that. We're just trying to show a little video. So apologies again for that. You know, technology is such. This is one of the problems with online meetings. You have no control over the quality of the internet. Right, so just do the quiz, don't worry about that. Let me just tell you why we need the temperature sensors, and that's a very good question. You need it, sir, because, Mr. Chairman, the temperature, the soil moisture probe is calibrated to operate optimally at a particular temperature. So if the soil temperature goes up above what it is calibrated for, then you have to make an adjustment in the reading. And that could make the difference between whether you should irrigate or should not irrigate. So that is why we have the correction factors. I mean, when I do this training course for a week, I show you what the correction factor is, how you must correct it, whether you go up or down. All right, but there are easy correction factors that you can apply. So that's a good question there that was posted by Sastry. Then there's another question. I think this is David Lawson or Yawson, and you're saying that you can specify the cultivar specifics in aqua crop 2, I use it for 10 varieties of barley. All right, you're ahead of me, my friend, and powers to you for that. I will say that my PhD was done with Accra crop, but the most of the work that I've done, my postdoc work, is now with DSAT. So I know of new developments in Accra crop. So if it can do that now, I'm very happy to hear that. What I found in general with Accra crop is that whilst you can specify the cultivar characteristics of model, the way it is actually done is slightly different from DSAT. But if it can do that, I'm very happy to hear that. So thank you very much for that information. Any other comment, Chair?
Whilst we're on the issue of water management generally,
Yes, Chair.
I feel we need to stress the differences in cultivars, and that if one is anticipating a water shortage or reduced availability of irrigation, then there are often, well, not often, there are sometimes cultivars that are more water tolerant, more salt tolerant. We haven't delved too much into salt tolerance for what we expect amid sea level rise, etc. But I want to re-emphasize that when you're taking a comprehensive view of climate smart agriculture, you have to go all the way back and forth in terms of you're not only interested in having a very efficient irrigation system, but we match the right cultivar with the available resources, so that, you know, far too often the emphasis is placed on the irrigation, the appropriateness of the irrigation technology, without making the further step to ensure that the correct cultivar for the conditions, such as they are, given market trends, etc., that are using the best cultivar for the environment that you're dealing with. And this is some of the work that is going to come up in next week's webinar when we start speaking about specific root crops. So I just thought I'd try.
That's very true, Chair. And I saw Lauren say you got 7 out of 10. Come on, people, we need to post our scores. So it's very good. Wow, Maury said they got 9 out of 10. Excellent. Mr. Chairman, I understand that you have a prize for everybody who get 9 out of 10, so that's very good.
Definitely. Contact Desi, all participants.
Okay.
So since I'm Maury, do I get a prize?
I understand that you are giving out the prizes, so if you are asking where the prizes are, we in real trouble.
Definitely.
Anyway, what you were saying a while ago, Steve, I almost said, I was trying to find an acronym to spell it SHE, S-H-E, salt, heat, and drought tolerant, but I couldn't find it. But anyways, those are the 3 types of crops that we need for the future. Salt tolerant, heat tolerant, drought tolerant. And so, yes, one of the problems that we have right now is that we have to start looking at that. How do we deal with that? How do we treat with that? And so one of the problems that we're facing right now in the Caribbean is we have to start identifying these things from early. Both the crop type itself and the variety itself, Steve, because that is something that is not easy. You cannot wait to plant the crop and see if it is going to work. You have to plant it virtually, you know, through things like, you know, the crop models and so on, and see what happens.
Sorry to interrupt you there, but if I were to hop back on what Christian mentioned in the very first session, not only are we looking to go to climate analogs like CARDI has been doing to get germplasm, but we have to be aware of the so-called heritage germplasm. There are some varieties literally floating around, you know, that we need to take another look at. And because we have not had really properly monitored germplasm collections, you know, we need to go back to that as a basic to be able to find the suitable cultivars for the new normal, the type of health and other modifications that we may need.
True. Very true. Mr. Chairman, if I can share my screen again.
Yeah. 2 minutes.
2 minutes, 1 minute. That's not sure. Can you see my screen? Can you see this map that I have on the This graph.
Insights.
Yes. So
Yeah.
so far, the average score is 6.8 out of 10. The median score is 10 out of 10. The range is between 5 and 8 out of 10. From 17 responses, you notice it is skewed to the right. So most of the persons are passing. So you've saved yourself, Mr. Chair. You did a good job. And so too did Dr. Simpson and Dr. Joe. I tried. You know, I don't know how well.
Your contribution was minimal, but it was
very minimal. Yeah, I agree.
Last one, the one that we tend to remember most, only because of the.
Yes,
I can assure you.
Yeah, but no, the average has gone up to 6.9, Mr. Chair. So even if we had used 7 as a mark,
yeah,
people would have passed, I would say. So congratulations to everybody. Really appreciate that, Mr. Chair. Over to you. I am done. Take care.
I am first to agree with you that you are done, but I want to thank all participants who have put up with us for this fourth issue. I can tell you that I, with my adult brain, learned today. I'm asking you all to please turn up next week. I know that there have been some comments about the predominance of males as presenters, but I can assure you that in week 4 and 5, we're going to have females presenting as well. We had females doing the real heavy lifting in the first week of the seminar. Behind the scenes, Desi and Clark Harris, so please do not think that it is skewed in any sort of gender way. So thank you for staying with us, and to invite you to attend following next week, where we have sessions conducted on climate smart agriculture with specific reference to root crops of importance. And we're looking forward to greeting you at 10 Jamaican, 11 Eastern Caribbean time next week, Tuesday. So from the Spice Isle, this is your moderator, thanking both presenters and the people in the background for today's session. Thank you very much.